Assalamualaikum dear students. Hope you all will be fine. In today's class, we will discuss the chain rule and parametric equation. And we are in the third class of calculus and analytical geometry. I have some objectives for today's class. The first objective is we will find the chain rule for the composition of two functions. Then we will apply this rule, this chain rule together with the power rule and product and quotient rule. Then we use this rule for the parametric equation, and with the help of this rule we find the derivative of the parametric equations. Chain rule is used to find the derivative of the composite functions. Here we have the definition of the chain rule. If f of u is differentiable at the point u equals to g of x, and g of x is a differentiable function at x, then the composite function f of g of x is differentiable at x, and f of g of prime of x, which is equals to f dash of g of x into g dash of x. We have already discussed the composite functions. Here in this lecture we will find the derivative of those composite functions which we have already discussed in previous lectures. So for this purpose we define the rule, and then we find the derivative of those functions. In Leibniz notation, if we recall the Leibniz notation, if y equals to f of u, it means y is a function of u and u is a function of g. U equals to g of x, which is u equals to g of x, g is a function of x, and we put u equals to g of x in f of u, then dy by dx, which is equals to dy by du with product du by dx, and where dy by du is evaluated as u equals to g of x. In simple words, हम लोगों ने पहले पढ़ा हुआ है कंपोजिट फंक्शंस. इन चेन रूल हम लोगों के पास यूज होता है फंक्शंस का, जो कंपोजिट फंक्शंस होते हैं उनका डेरिवेटिव फाइंड करने के लिए. और उनका डेरिवेटिव फाइंड करने के लिए जिस वक्त हम उसके ऊपर कंपोजिट चेन रूल लगाते हैं वो इक्वल होता है एफ प्राइम ऑफ जी ऑफ एक्स एंड इनटू जी प्राइम ऑफ एक्स. और अगर हम लोग y इक्वल्स टू एफ ऑफ u पुट करें और u को g of x फंक्शन पुट करें, तो देन बाय चेन रूल dy by dx which is equals to dy by du multiply du by dx. In this example, we have an object that is moving along the x-axis, so that its position at any time t greater than or equals to 0 is given by x of t, which is equal to cos of t square plus 1, and we want to find the velocity of the object as a function of t. We know that x of t is the position and velocity is the derivative of the position dx by dt. Basically, in this example, we want to find the derivative of this function. So in the solution, we first put the function in t square plus 1 equals to u. When we put t square plus 1 which is equals to u, the function that is the position becomes x equals to cos of u, and we have u equal to t square plus 1. Then for the chain rule, we find the first derivative we will find is dx by du, which is equals to minus sine of u, and the another derivative is du by dt, which is equals to 2t. Then we apply the chain rule. So dx by dt equals to dx by du with du by dt. Then we put the values of both the derivatives, and after simplification we obtain dx by dt, which is equals to minus 2t sine of t square plus 1. Outside inside rule. By the name of this rule we can guess there is something outside and something inside. So now we will see what is outside function and what is inside function. If we consider y equals to f of g of x, that is a composite function, and we want to find the derivative of this composite function, such as dy by dx, which is equals to f prime of g of x into g prime of x. In words, differentiate the outside function, that is f, and evaluate it, and the inside function g of x left alone. Then multiply by the derivative of the inside function. Here we have the example. Find the derivative of sine of x square plus x with respect to x. We will apply the derivative on this function. The derivative of the sine of x will become cos, and the derivative of the angle, which is the inside function, x square plus x, which the derivative of x square plus x becomes 2x plus 1. So the answer will be 2x plus 1 into cos of x square plus x. This example have two parts. The first part is find the slope of the line tangent to the curve y equals to sine power 5x at the point where x equals to pi by 3. First thing, when we want to find the slope of the tangent line, then there will be no ambiguity in your mind that how can we find. You will directly take the derivative of the given function. So here is the given function is y equals to sine power 5x, and so we will calculate the derivative of this function. For the derivative, we will apply the d by dx on both sides of this function. So it will become dy by dx, which is equals to, we will apply the power rule on sine power 5x. So it will take the form 5 sine power 4x, and the derivative of sine of x is cos of x. And for the tangent line has slope at x equals to pi by 3. When we put this x equals to pi by 3 in the slope dy by dx, we know that pi by 3 is 60 degree, and sine of 60 degree, which is equal to under root 3 by 2, and cos of 60 degree, which is equal to 1 by 2. We will put the values of cos and sine in this slope, and after simplification we have the slope of the tangent line in the form of 45 by 32. In the second part, show that the slope of the every line tangent to the curve is y equals to 1 by 1 minus 2x power 3 is positive. Here in this step, we want to show that the slope of every line is positive. That is given on the curve. So for the slope, we will calculate the derivative. For the derivative, we will apply the dy dx on the given function, and the given function is y equals to 1 by 1 minus 2x power 3. We can apply three rules. The first rule is power rule for negative integers, and the second rule is quotient rule, and the third rule is power chain rule. So it's up to you. You can choose any one of them. When we apply the derivative on the given function, so after simplification we have 6 by 1 minus 2x power 4, and this is the slope dy by dx, and this function will be undefined when we put x equals to 1 by 2. So x equals to 1 by 2 के अलावा तमाम फंक्शंस पे, तमाम पॉइंट्स पे ये फंक्शन एग्जिस्ट करता है, and the slope of the tangent line is dy by dx is 6 by 1 minus 2x power 4. और अगर इस जो हमारे पास गिवन स्लोप आई है, इसमें जितने भी नेगेटिव नंबर्स पुट करते रहे, ये स्लोप ऑलवेज पॉजिटिव रहेगी. क्यों? कि हमारे पास जो डिनोमिनेटर में 1 माइनस 2x है, इसकी होल पावर 4 है, दैट इज अ इवन नंबर. तो अगर हम लोग नेगेटिव नंबर b पुट करेंगे तो ये उसको पॉजिटिव करता रहेगा. सो वी हैव द स्लोप which is a positive. Now we have the parametric curve and the parametric equations. If x and y are the given functions such as x equals to f of t and y equals to g of t, here x and y are both dependent variable, and these dependent variable depending upon the independent variable, that is t. If x and y are given functions over an interval of t values, then the set of points x equals to f of t, y equals to g of t defined by these equations is a parametric curve. The equations are parametric equations for the curve. In this definition, हमारे पास कि हम अगर कोई भी पैरामीट्रिक कर्व फाइंड करना चाहते हैं तो वो हम लोगों के पास आएगा इस सेट ऑफ पॉइंट से, सेट ऑफ इक्वेशन से। ये x इक्वल्स टू एफ ऑफ टी एंड y इक्वल्स टू जी ऑफ टी ये सेट ऑफ इक्वेशंस बनाती हैं, और ये सेट ऑफ इक्वेशंस जो है ये हमें बताती हैं, ये पॉइंट्स हैं, ये बेसिकली कर्व के डिफाइन करते हैं पॉइंट्स को। इनकी हेल्प से हम लोग कर्व के पॉइंट्स डिफाइन करते हैं। सो इन सेट ऑफ पॉइंट्स से हम लोगों के पास जो कर्व बनता है उसको पैरामीट्रिक कर्व कहते हैं, और इन इक्वेशंस को पैरामीट्रिक इक्वेशंस कहते हैं। नेक्स्ट वी हैव स्लोप ऑफ पैरामीटराइज्ड कर्व। तो हम लोग स्लोप पैरामीटराइज्ड कर्व की किस तरह से फाइंड कर सकते हैं, क्योंकि पैरामीटराइज्ड कर्व में हमें पता है कि इक्वेशन x इक्वल टू एफ ऑफ टी होगी और y इक्वल टू जी ऑफ टी होगी, तो वो हम लोगों के पास फंक्शन कब, ये दोनों फंक्शन कब डिफरेंशिएबल होंगे एट टी पे, व्हेन f एंड g आर डिफरेंशिएबल एट t, जब f और g डिफरेंशिएबल होंगे। सो वी कैन फाइंड द स्लोप ऑफ द पैरामीटराइज्ड कर्व विद द हेल्प ऑफ डेरिवेटिव dy by dx which is equals to dy by dt divided by dx by dt. In this example, x equals to 2t plus 3, that x is a function of t, and y equals to t square minus 1, that is y square, y is also a function of t, and we want to find the dy by dx, that is the slope of parameterized curve, because these equations x equals to f of t and y equals to g of t is a parametric equations, and find the slope of slope, that is dy by dx at t equals to 6. For the slope, we know the formula dy by dx, which is equals to dy by dt divided by dx by dt. So first we will calculate dy by dt. For dy by dt, we apply the derivative d by dt on the function y equal to t square minus 1. The answer will be 2t. And for dx by dt, we apply the derivative d by dx on the function x equals to 2t plus 3. And the answer will be 2. After substituting the value of these two derivatives in the formula, we obtain 2t by 2, which is equals to t. And we know that from x equals to 2t plus 3, we find the value of t, x minus 3 divided by 2, which is equals to t. And next in the question we have find the derivative at t equals to 6, and t equals to 6, the slope which is equals to 6, because there here we have no variable involved in the slope, that we put the value of this given function, and we obtain the slope in the form of any variable. So we have the slope of the given function, that is a constant. Have the parametric formula for the second derivative d2y by dx2. We know that we have the parametric equations, that is x equals to f of t, y equals to d of t, and the first derivative of this given function is dy by dx, which is equal to dy by dt and dx by dt. So for second derivative, we will apply the d by dx on both sides, and with the help of chain rule, we find d2y by dx2, which is equals to dy prime by dt divided by dx by dt. In this example, find d2y by dx2 as a function of t if x equals to t minus t square, y equals to t minus t cube. For d2y by dx2, we first calculate dy by dx. For dy by dx, we first calculate dy by dt and dx by dt. dy by dt is 1 minus 3t square, and dx by dt 1 minus 2t. For the second derivative d2y by dx2, we first calculate dy prime by dt. Y prime we have y prime is dy by dx, And for dy prime by dt, we will apply the derivative d by dt on dy by dx. When we apply d by dt on both sides of y prime, we obtain 2 minus 6t plus 6t square by 1 minus 2t whole square. And next, in the next step, we will put the value of dy prime by dt, and from the previous step, the value of dx by dt we will put here. So d2y by dx after d2y by dx2 after simplification will become 2 minus 6t plus 6t square divided by 1 minus 2t whole cube. Some standard parametric equations for the circle and the ellipse. The standard parametric equation for the circle is x equal to a cos of t and y equals to a sine of t. We put x equals to a cos of t in the equation of the circle on the left side of the circle. Then we take the square on both sides. X square equals to a square cos square t. Similarly, we put the value of y square, that is a square sine square t. After substituting and simplification, we obtain a square, that is equals to the right side. And similarly, we can find the equation for the ellipse, and the parametric equation for the ellipse is x equal to a cos of t and y equals to b sine of t. When we substitute in the similar pattern the equations x equals to a cos of t, b equals to sine of t in the equation of ellipse, or after simplification we can obtain equals to 1. It's time to finish our today's lecture. In this lecture, we have studied the chain rule for the composition of two functions. We applied the chain rule together with the power rule. Also, we applied the same chain rule to describe the parametric curve, parametric equations, and their tangent lines in another way.